Part 4, using the sine and cosine ratios to calculate lengths. So, a surveyor can measure a horizontal angle precisely using an instrument called a transit. The surveyor places stakes at certain spots and measures one of the distances directly with a tape measure, trundle wheel, or other such measuring device. The transit then is used to measure the angle of the triangle. Okay, then we can use indirect measurement to, say, measure the distance across the lake. Something like that. Okay, awesome. A vertical angle can be measured with a device called a clinometer. Okay, so that one measures angles going upward. Okay, anyways, awesome. Okay, so we can use the sine ratio or cosine ratio, or even tangent, okay, to write an equation that we can solve to calculate the length of a leg in a right triangle when the measure of one of the acute angles and the length of one of the other sides is known. Okay, so example, using sine or cosine ratio to determine the length of a leg. Okay, so determine the length of PQ to the nearest tenth. So PQ is this guy. So PQ, we can call it X if we really want, or just leave it as PQ. It doesn't matter. Okay, so look, they give us 67 degrees. So because they gave us that one, we can use that to solve, or just use our SOHCAHTOA from. So SOHCAHTOA. So we name the side. So PQ is the opposite. 10.4 is the hypotenuse. Okay, so opposite hypotenuse, that is sine. So we go sine of 67 equals opposite, so that's PQ, divided by hypotenuse, so that's 10.4. Awesome. So we've seen this before with the tangent ratio, just now we're going to press the sine button instead. So look, the 10.4 multiplies up, so 10.4 times sine 67 equals PQ. Remember, I don't need to see this step. You can go right to PQ equals if you want to. Okay, some people need to write that down so they know what they're doing. Others, you've got this down, go ahead. So now we just type that in, 10.4 times sine 67. Okay, remember, again, it's sine, not sin. Lots of kids like to say sin. Okay, no, it's sine. Okay, so either way, so 10.4 times sine 67 is 9.6 centimeters. Boom. Okay, and there you have it. Okay. Part B. Determine the length of BC to the nearest tenth. So let's see. BC is this guy. So BC. Okay, easy enough. So we have to label the sides. So from the 50 degrees, that's what they've given us. So from 50, BC is the adjacent side, and 5.2 is the hypotenuse. So we have the A and the H. So, oh look, A and H is cosine, ka. So cosine of our angle, so cosine of 50 degrees, equals the adjacent, so BC, over the hypotenuse, so 5.2. Okay, again, that multiplies up. Okay, so BC is going to equal 5.2 times cosine of 50. When you type that in, you get 3.3 centimeters. And that's how it works. Okay, so very similar to the work we did in part 2, just now instead of the tangent ratio, we're using the sine and cosine ratios. Okay. So example 2 here. Okay, so determine the length of JK to the nearest tenth of a centimeter. Okay, so when you do that, how that works out. So length of JK, so that is this side here. So I can write JK, or I can just put sine or X if I want. Doesn't really matter. Okay, so let's see. Here's our angle. Okay, there's our side length. So we label everything. So that's opposite. This is hypotenuse. Okay, so for SOHCAHTOA. Okay, so opposite hypotenuse, so now I'm using sine. So sine of my angle, so 65 degrees, equals opposite, so 7.6 divided by the hypotenuse. So see, now the hypotenuse is on the bottom. So remember, when we had this with tangent, we either cross multiplied and divided, or remember how that worked out is that the h and the sine 65 just traded places. So h equals 7.6 over sine 65. Now a couple of words here just about reasonability. Okay, remember the hypotenuse is always the longest side of the triangle. So the thing is, if we do this properly, the hypotenuse should be bigger than 7.6. So if we get an answer of, say, 5.2, we know we've done something off. Does that make sense? The hypotenuse has to be the biggest side, so it has to be bigger than 7.6, at least in this case. So anyways, called that h, really. Okay, so I called that x, which of course is jk. Either way, we go 7.6 divided by sine 65. So let's just type that in really quick. 7.6 divided by sine 65. Okay, and we get nearest tenth, so that is 8.4. And then there are units on this, so 8.4 centimeters. So there's our answer for that one. Awesome. Okay, marvelous. Okay, B, determine the length of DE to the nearest tenth. So DE is this one. Okay, so we can just write DE this time. It doesn't matter. Okay, so let's see. So labeling from the 55. Okay, 6.8 is the opposite. DE is the hypotenuse. Oh, opposite hypotenuse, that's sine again, right? SOHCAHTOA. Okay, so sine. So sine of 55 degrees equals the opposite, so 6.8 centimeters divided by h. Now, look, guys, remember, we don't usually put the units on while we're calculating stuff. We can, but it just tends to get in the way. So we switch those two. That's been our methodology here. Okay, so the hypotenuse, or I guess DE, so DE equals 6.8 divided by sine 55. Okay, when you type that in, 6.8 divided by sine 55. 6.8 divided by sine 55. Okay, that works out to 8.3 centimeters. Now, does that answer make sense? It is certainly longer than the 6.8. The hypotenuse should be longer, so we are good to go. That is our answer. Awesome. Okay, so example 3, using indirect measure. Okay, not a problem. Okay, so from a radar station, the angle of elevation of an approaching airplane is 32.5 degrees. The horizontal distance between the plane and the radar station is 35.6 kilometers. How far is the plane from the radar station to the nearest tenth of a kilometer? Okay, so again, I'm going to write SOHCAHTOA right at the top here. Okay, so I've drawn the picture for you. So from the 32.5, I have this side, that's the adjacent side. Okay, and how far is the plane from the radar station? So this is the required distance here, and that is the hypotenuse. Oh, well, that's A and H. So A and H is the cosine. So cosine of my angle, so 32.5 degrees, equals the adjacent, so 35.6 kilometers, divided by my hypotenuse, or my required distance. So we could just call that D. I guess we could leave it as H too. It really doesn't matter. Okay, so D for distance Okay, so this is one of those switch ones again. So D equals 35.6 over cos 32.5. And when we type that in, it works out to 42.2 kilometers. Marvelous. Okay, and that answer does make sense because it's the hypotenuse, so it is bigger than the other side, 35.6. So it makes good sense. Okay, so for B, and sorry guys, I know the pictures didn't show up all that good on your black and white notes. Sorry, but here's some color, and I guess they're not too bad, but still, a surveyor made the measurements shown in the diagram. Determine the distance from the transit to the survey pole to the nearest hundredth of a meter. So, the survey pole, okay, and the transit. So that's what I want to figure out the distance of. Okay, not a big deal. Okay, so from here, from that angle, we label the sides. So my 20.86, that is the adjacent. Okay, the distance from the transit to the survey pole, okay, that is the hypotenuse. So let's call that x, whatever, it's fine. But it's the hypotenuse. So we have adjacent and hypotenuse. So adjacent, hypotenuse, hey, that's the cosine again, so katoa. Okay, so this is cosine of the angle, which is 67.3 degrees, equals the adjacent, so 20.86 meters, divided by the x. Okay, so we switch those two again, because that's been what we've been doing. So 20.86 divided by cosine of 67.3. Okay, we divide those, and on our calculator, it just works out to 54.05 meters. Okay, round to the nearest hundredth, so awesome. Okay, so that's it for this section, everybody. I need you to practice this. It's 2.5 in your textbook, starting on page 101. Please do all those questions and make sure you show your teacher when you're done so they can keep track of your progress. Thanks so much. We'll see you next part.